হ্যাঁ, সবাই।
Okay, good evening, everyone. Um, my name is Rajesh Bhatt, and I am the TA assigned for the course on integrated waste management for smart city. Today is the second live session that we will be having for this course. That is the week 2 live session. And just a brief introduction about myself. I am doing my PhD from IIT Kharagpur under Professor Rajesh Kumar Dubey, and as a part of PMRF TA-ship duties, we have me along with my other friends. We are doing this NPTEL courses as a TA, and across this course and various live sessions, we will be discussing 15 questions, particularly in each live session. Apart from that, if you have any questions, any queries, or anything that you would like to share with us, discuss with us, this platform can be used for that as well. So today also we will be discussing 15 such questions. It will be a mix of both numerical based ones and theoretical ones. I can see that still few are joining, so we can wait for another 2-3 minutes and then we will start discussing the questions. Okay, so we will start our session now. I'm just sharing my screen. I hope it is visible. Please feel free to interrupt me at any time if you have any doubts or anything else to discuss. And I will start sharing the questions. And how this will go is that I will type the question, provide the answers like options. It will be mostly multiple choice and true and false. And then you will have couple of minutes based on the type of question to choose an answer. You can either unmute yourself or you can use the chat box, whatever way you feel comfortable to let us know what answer is correct. Okay, so the first question is, so the question is that in landfill degradation process, acetic acid is formed, and which of the following options of the substrate, so not the substrate, the microbe, is responsible for that, for the production of acetic acid. So your option are acidogenic bacteria, aerobic bacteria, methanogenic bacteria, or anaerobic bacteria. So again, I will repeat the question that acetic acid is formed during landfill degradation processes. When the microbes present there, they act on a substrate. So which microbe is responsible for the production of acetic acid? One of the options that I can see, option D, Mohammed Hashim has chosen option D. Okay. I will wait for a couple of more minutes for others to. So I will be basically asking two type of questions based on this particular statement. One is what is already written here, and another one I will also ask. So in here it is written that acetic acid formed in landfill degradation process is the substrate for which of the following specific microbe. Sorry, so that means that which of the following microbes they eat acetic acid as their food. This is one question. And another question that I would like to ask is that which of the microbes among these are responsible for the formation of acetic acid? And for that question, it can be one of the options and it can also be something else. Okay, so I can see some of the options. Yes, methanogenic is one of the correct answers. Reason being, like when acetic acid is formed in landfill, that formation of acetic acid is basically due to a certain group of bacteria which are called acetogens. The spelling is of that is, I will, sorry. acetogens. These are the group of bacteria which convert VFAs. VFAs means volatile fatty acids into acetic acid. So acetogens, they convert the volatile fatty acids into acetic acids, and the acetic acid that was formed, it was then further taken as a substrate for methanogenic bacteria. These methanogenic bacteria, they eat acetic acid and go forward to produce methane. I hope this question is clear. Now moving on to the next question. If you have any doubt, please feel free to interrupt me. In the upcoming questions, I will also be explaining in detail about these degradation processes that are taking place in the landfill, and it's discuss some of its phases. So our next question is maximum BOD occurs in which phase of the waste stabilization process in landfill? So during which phase of waste stabilization in landfill the BOD is maximum? Your options are preliminary aerobic phase, acid forming phase, final aerobic, or methane forming phase. Along with this, I would like to post another question, that what is the full form of BOD and what does it signify and what is the meaning of it? I will repeat the question again. During the degradation of waste that is dumped in landfill, it goes through various stages. The four primary stages are preliminary aerobic, acid forming, methane forming, followed by final aerobic. Among these four stages, during which stage is the BOD maximum? First question is that. Second question is what is the full form of BOD? And third question is that, like, why do we use BOD? What is its significance, like that? So, and if anyone is comfortable, they can also unmute themselves and share their opinion on this. Yeah, I can see some of the answers. Option B, most of them are saying acid forming phase. Okay, yeah. And biochemical oxygen demand is the full form of BOD. Yes, it is absolutely correct. Why I have asked this question is that because often, sometimes during interviews or some other viva or something like that, we often, instead of biochemical oxygen demand, people often mistake it for biological oxygen demand. So just to clarify that, I have put forth that question. And the correct answer for this question is acid forming phase. That is true. And I will show you one graph to explain this further. So as you can see in this particular graph, the four phases of landfill are shown here. First is the preliminary aerobic phase. This is the phase where the this oxygen demand, it starts increasing. You can see that it increases during the acid forming phase. It reaches its peak in here, and then it starts falling and almost reaches to zero or kind of zero, and during the methane forming phase. So the correct answer is acid forming phase. It is where the BOD is highest and the acid, this VFA concentration, that is the volatile fatty acid concentration, is also highest. And why this VFA is highest? It is very obvious that the name itself, if you look at it, it is an acid forming phase. So what happens is that uh, whenever we have a certain waste and I am trying to degrade it anaerobically, it passes through few steps, and I will just write them here. So the first step is hydrolysis. During this step, what happens is that whenever I am degrading any material, my microbes are working on it, there are big macromolecules. So those macromolecules will be broken down by the action of water and microbes present in there, and that is what is known as hydrolysis. The term itself is self-explanatory. So once the macromolecules it has broken down to form smaller fragments, then it is easier for the microbes to further work upon it and eat it as its food. So after that, what happens is that acidogenesis. In acidogenesis, what happens is that during this phase, volatile fatty acids are formed. These may include acetic, propionic, butyric, such acids, and this is the mixture that is available in acidogenesis. What happens there? Then after acidogenesis, the VFAs or the volatile fatty acids which are formed, they are further degraded to acetic acid. So this stage is called acetogenesis. And after acetogenesis, we have a final phase which is known as, what is the final phase here? Methanogenesis. So acetic acid which was formed, it gets converted to methane. So that is where the methanogenesis, the final phase. So in methanogenesis, methane is formed. And among all these four steps, these are all driven by their individual set of microbes. And among all these, the most sensitive group of microbes are the methanogens. Because, for example, if there is a slight fluctuation in the pH of the feedstock or the food that we are giving to the microbes, or there's a sudden change in temperature, or in fact, if the amount of food that has been given to the microorganism that also increases or decreases sharply, so these kind of microbes which belong to the methanogenesis group, they are very susceptible to such changes, abrupt changes, and can easily die off in those conditions. So we often see that in any anaerobic process, it is, first thing is that it is a very slow process. It takes some time for the microbes, these methanogens, to get accustomed, to get acclimatized, then they start producing methane efficiently. But if there is any fluctuation in their kind of feedstock, loading, pH, any concentration changes there, for example, suddenly some poisonous material is present in the material that is to be degraded. So the methanogens, they die very quickly. So this is one of the very crucial part of any anaerobic degradation process. So another question that I asked was, what is the significance of biochemical oxygen demand? And that would mean, like, what is biochemical oxygen demand? Why do we use this particular way to determine the amount of organics present in wastewater? And any other points that you would like to address or share on this particular aspect? Okay, so Manu, Anath, I can see that the answer provided is that biochemical oxygen demand is the amount of oxygen required to decompose organic matter by microorganisms. Okay, yeah, this is basically what we are trying to determine. Anything else that you might want to share? You're always free to unmute yourselves and discuss any points that you might want to add on to this or anything else. Higher BOD means higher the pollution and lower the oxygen content available. Okay, yeah. Okay, fine. So I will share my opinion on this. So as correctly said that biochemical oxygen demand is the amount of oxygen required to decompose an organic matter by microbes. And there is, since wastewater or any other water stream, it may have a huge mix of different kinds of compounds, particularly organic compounds. So it is very difficult to get the concentration of those organic materials that is present in our water body or anywhere else. So what we do is that we know that one of the characteristic property that these organic materials they exhibit is that when I throw it into the environmental matrix, they the microbes act on them in an aerobic condition. The microbes act on them, they consume oxygen and degrade them to mostly CO2 and carbon monoxide when this conversion is not complete. So mostly it is CO2. So what happens from the analogy I will take, like dumping the sewage into wastewater. If I am dumping my sewage into wastewater, first things first, our sewage has got a huge organic loading. The COD of the sewage is easily more than 300 milligram per liter, and it can go as high as often 800 milligrams per liter. So BOD is a bit less than COD, 0.67 times, I think, for the ones which are readily biodegradable material. For them, the BOD is equal to 0.67 times the COD. So what happens is that when I dump such waste into the water body, it starts consuming oxygen. So that is how we correlate the amount of organic material that is present in that water body, because there is no way to directly estimate their amount. So we try to correlate it with higher the oxygen being consumed, that means more organic material must be present. So that was the motivation, or like the goal, when people started estimating this biochemical oxygen demand. So as you might know that ideally biochemical oxygen demand is being determined for a time period of 5 days and temperature of 20 degrees centigrade. That is the standard way how BOD is being determined. So, and why we use those 5 days, that time, and 20 degrees centigrade the pressure? Can anybody, does anyone have any opinion, or any, someone can guess that? Like why that 5 days there, and why that 20 degree centigrade temperature, incubation time and temperature? Any guess?
Sir, at 5 days, 20 degrees Celsius, almost all the 60% of the bacteria will consume the organic matter. So we'll consider like
Okay, so if like that is one of the most frequent answers that we receive. But if I go with that explanation, then why not? Why am I doing for 5 days? I can just increase the temperature to 27 and do it in 3 days, because then let's say 80 or 90% of the bacteria, sorry, of the organic material will be consumed. Like why just 60% we are assuming, not 80% or 90%? What you have told is correct, but if I take that example, then I can increase the temperature to 27. The microbes will start eating the food faster, and we can get 80% removal of the organic matter, let's say in 3 days. It's the reason why it is 5 days and 20 degrees centigrade is that, like, there is no, if you want to put any logic behind it, there will be no logic behind it except one, is that the biochemical oxygen demand, it was standardized in England. So the place where they were trying to determine this biochemical oxygen demand, it was somewhere on the river Thames, and the intention was that when I am dumping the uh, sewage or material into Thames at that particular point, it took about 5 days for that group of, or that sample of water to reach the ocean. So the researchers or the people there, they decided that yes, within 5 days before it reaches the ocean, the organic material should get degraded. So that is why they took that 5 day time period. And the reason behind that 20 degrees centigrade is also related to the geographical significance, because in England, the temperature at that time is somewhere around 20 on. So these two were the main reasons. So what happened is that, like, if you want to go to some field visit or some other place and you want to determine the standard biochemical oxygen demand, then practically speaking, you won't have the time. You are going on a field visit to some industrial plant, let's say, who is making this dairy plant or any juice industry where they are producing effluents, organic rich effluents, and you have been told that you want to understand, or you want to check if that industry, they are treating their effluent properly before discharging it into a water body. So that is your duty. So how will you invest 5 days and maintain that 20 degrees centigrade temperature, because you are going on a field visit? Firstly, you are not having your equipment, you are not taking a refrigerator, and you don't even have 5 days, because you have to get the results as quickly as possible. So that was one challenge. So what we do in India is that frequently, instead of doing BOD at 5 days, incubation time and 20 degrees centigrade of temperature, what we do is that we often see here the temperature is obviously much higher than England. So the standard we often use here is that incubation period of 3 days and temperature of 27 degrees centigrade. So that is one way where we can shorten the time for BOD calculation. But still, if you're going to someplace, you don't have 3 days time usually because you're on a like timeline and you want to get that done as quickly as possible. So in those cases, what we do is that we never determine the BOD, we straight away go and determine the chemical oxygen demand. And after we have determined the chemical oxygen demand, which is a much quicker process, we correlate it with the BOD because there is a BOD to COD ratio for different kind of waste streams. Based on that, we estimate the BOD and then we check that whether it is falling within the limits or not. So this is how BOD, COD, these are being used at an industrial scale. So moving on to the next question. Please feel free to interrupt me whenever you have any doubt or you want to share something from your experience. Okay. Yeah, so in the meanwhile, I would also like to state a few points on this particular graph. You can see here that as I just mentioned, VFAs and BOD both are increasing in acid forming phase and then they follow a declining trend. At the same time, it is very obvious that you can see that pH, due to the increase in acid, the pH also falls around the same point and then it reaches again, increases up to a certain level when the methane forming phase starts and becomes kind of constant. So this was the last point. Then moving on to the next question. It is very easy. What is the typical composition of gas generated from or generated during waste stabilization of landfills? Your option are 60% methane, 40% CO2, 50% methane, 50% CO2, 40% methane, 60% CO2, and then finally 90% methane and 10% CO2. So which one do you think is correct?
Option 1, sir.
Yes, absolutely correct. Option 1 is the right answer. Obviously, we know that during waste stabilization in landfills, it is an anaerobic process. So we already can guess that methane will be formed. And I will show you one graph where you will understand that why methane is more than your CO2. So you can see in the screen, I will zoom this a bit. Like when the landfill has kind of stabilized, you can see that the CO2 initially is higher. It is in the acid forming stage where the CO2 is more. But once the methane forming starts, it is very obvious that in methane forming, the methane production will increase drastically. You can see that the methane forming is increasing. And during this stabilized stage, you can see that methane is somewhere more than carbon dioxide, this green line. And usually or typically, it is about 60% is methane and 40% is carbon dioxide. But if you really dig deep into it, you might also see trace amounts of hydrogen sulfide also. So that was the correct answer. So moving on to our next question. And this is kind of an assertion and reason based question. I will give you two statements and then based on those two statements, you have to choose a correct answer. So statement A is in TCLP test, the solid waste particle size is reduced to less than 1 centimeter. This is the first statement. And then the reason behind this is the finer particles have more surface area, and that helps in yes. So the first statement is that in TCLP the solid waste particle size would be less than 1 centimeter, and the reason that this option states is that the finer the particles, more is the surface area, and that helps in improving the reaction rate significantly. So in here the options I will just tell you orally, or I will just write it here briefly as well. First is both A and R are true, and R is the correct explanation of A. Fine. That is one option. Second option is also that both A and R are true, but R is not the correct explanation of A. Then third is A is true, R is false. Option 4 is A is false, R is true, and option E is both A and R. So which one do you think is the correct one? Any guesses? It is a very conceptual question, and I think it must be very easy to guess.
First option.
First option, absolutely true. For any particular reaction, the smaller the particle size, the more surface area it gets, and the faster the reaction progresses. It is true for biochemical reactions, for thermochemical reactions, both of them. So that was right. Moving on to the next question. So next question is related to a true and false. It is that TCLP test simulates the worst case scenario of a waste. So this is a true and false question. The statement is TCLP test simulates the worst case scenario of a waste leachability within the municipal solid waste landfill. So if your answer is true, please share with us like why do you think it is true, and if it is false, then why so.
It's true because the intent of this test is to understand if the waste can go into an MSW or is it a hazardous waste.
Yeah, correct. That is the basic intent behind it. So have you guys already been taught like how TCLP is being done in labs and in the classes that has been going on? Was it taught there already, or is it about to be taught? So whatever will be the reason, I will just explain it briefly, like what is basically TCLP. So as you correctly stated, that intent is to determine whether a certain waste it exceeds a toxic limit and is hazardous or not, so that it is not being disposed in a landfill. So before I dispose any kind of waste into the landfill, I have to pass it through TCLP test. If the leaching is below the standard limits, then it is fine, we can dispose it there. Otherwise, that material will be within that hazardous waste category. And as per this EPA, US United States Environmental Protection Agency, it is not recommended that such waste should be dumped into the landfill. Now what happens is that we first reduce the size to less than 1 centimeters. Then in landfill, I have already shown you here that in acid forming stage, acetic acid, volatile acid, fatty acids, those things are formed. So then those small, less than 1 centimeter size of waste material, it is being mixed rapidly in an acidic medium to simulate the conditions in landfill. And if after all those mixing and all those movement and agitation, if I am finding that the contaminant level in that liquid, that aqueous phase, it has exceeded a certain permissible limit, then it is not recommended that the waste should be thrown into a landfill. So obviously some of its basic objectives are, it can help us identify which kind of waste is hazardous. Based on that, various environmental protection steps can be taken, and the management and disposal of those particular waste should be done separately, and that will also help us in building a different management plan as well. So this is what some of the objectives or goals of TCLP are. Then moving on to the next question. So there is a waste to energy concept. You already know that. The statement is that why is waste to energy conversion unsuitable for waste which has got very high moisture content? I will also write it here. Waste to energy not suitable for high moisture content wastes. So you have to guess that answer, like why it is not suitable. Option is okay. So which one do you think out of these four options is correct? That kind of waste which have got very high moisture content is not suitable for waste to energy concept or that kind of disposal method. An example I can give you based on this, and supposedly that you are a waste management engineer, you have to suggest, like based on that waste type, which kind of management approach I can take. So your waste is basically food waste generated from hostels in various colleges or restaurants. So this is the kind of waste that is being generated, food waste. It might have all those leftover food, vegetable peelings, waste part of those vegetables and all those. So this is the kind of waste. This is one of the questions, that if such kind of waste you are getting in your plant and you have been told that you have to treat it, which kind of treatment will you suggest? And another first question was this. So please share your opinion on this. Okay, so I can see few options. High calorific value needed for combustion. Yes, absolutely true. The waste should have high calorific value. Muhammad Hashim has suggested option B, that is the latent heat of vaporization is high for water compared to other compounds. Okay. Heat required is more, absolutely true. Yes. Most of you are absolutely correct that the correct answer is option B. Because of course, if I have a material, I have to burn it in the process of combustion. So basically it is an exothermic process. And when I'm doing it, burning a certain waste material which has got good calorific value, it during combustion it will produce energy, and that energy can then be used for different applications, like I can generate electricity from it. I can use it, the heat produced, for any other industrial applications. So like that. So if I'm having a waste material which is having high moisture content, a huge portion or a significant portion of that heat will be first consumed by that water itself. It will be lost to convert that water into vapor phase. So that was the correct answer. So the next question was food waste generated from hostels or restaurants, which can be a good way to deal with it. So one of the answers that I can see here is composting is suggested as one of them. Anything else apart from composting? Biogas generation, okay. Yeah, I can see that someone raised their hand. Anaerobic digestion, yes. If someone wants to say something, you don't need to raise your hand. You can just come up and speak. I can see most of you are going for composting and anaerobic digestion. These are the correct ways wherein you can treat such kind of waste. The point is that, for example, during composting, I think in the last live session also I highlighted that during that we need to maintain a certain amount of carbon to nitrogen ratio, 20 to 25, which is optimum, so that the composting occurs in a nice way. And the water content should also be, I can't exactly recall the water content, but it should not be very high, because you can visualize that I am trying to prepare a compost. The texture should be kind of like peats or soil kind of texture. So if it is entire like a sewage sludge or something like that, it shouldn't be used for composting. So based on the type of food waste that is generated from hostels, like we often see that huge amount of this cooked vegetables, curries, dal, and all of these are generated. So I can't just use, in those scenarios, I can't use that for composting. But if my food waste generates vegetable peels or those any leftover kind of vegetables which is not being used, uncooked vegetables like that, that can definitely be used for composting along with certain amount of cooked part also. But if typically the amount of cooked part, high water content, those curries and dal are there, then it is more suitable that it should be anaerobically digested. However, there is a catch in there also, because the cooked food, it has got appreciable amount of oil content, and often the microbes find it difficult to go past that those oil and then degrade the food material that is present there. And for this particular instance, when I am talking about these biological activities, I will, instead of food, I will use the term substrate, because that is what we usually use. So the microbes will find it difficult to consume the substrate. So what happens is that in those cases, we often first retreat our raw material, that is the food waste, through some techniques, and then we can also feed it to the microbes. Or another way can be, you add food waste to an anaerobic digester, let it stay there for suitable amount of time so that the microbes have got acclimatized to that kind of feedstock, and then the methane generation will run finely or nicely. So that was it. So moving on to the next question. Next question is, why do we perform ultimate analysis? And your options are Okay, so these are our options. Why do we perform ultimate analysis? This is quantification. Yeah. So you can guess or think about the answer and can share it in the chat box. And you can also like share a few points like what is ultimate analysis. Like ultimate and proximate analysis are two of the most frequently used uh, characterization methods that gives us information about the nature of the waste. So can you think of like which of these is the correct answer? And what is ultimate analysis? What is proximate analysis? Would anyone like to share their thoughts on them? So ultimate analysis is basically when we are trying to determine the carbon, hydrogen, nitrogen, sulfur, and oxygen content of a waste material. So this is what we do in ultimate analysis. In proximate analysis, we determine the composition of the waste, solid waste, in terms of its fixed carbon content, ash content, moisture content, and volatile matter content. So if I'm talking with respect to ultimate analysis, the correct answer will be that when I get this, what is the percentage of C, H, N, S, and O, these five components present in a waste product. So I can derive a more generalized formula, a chemical formula that solid particular solid waste can represent based on the composition C, H, N, S, and O fractions present in the solid waste. And once I have that composition, I can also quantify the amount of gases that can be produced. If not accurately, at least I can have some guess. For example, if I'm getting 20%, 30%, or 40% carbon content, based on that, I can guess like if I am 100 kg of waste material in that carbon, hydrogen, and all those stuff, it is percentage wise I have got the value. So assuming that I'm combusting it with oxygen, then X amount of carbon, when it reacts with O2, it will form X amount of CO2. So that mole wise, if you can try to relate with it, for example, I can give you one small example like C plus O2 CO2. So if we already know this. So for example, I know that 12 grams of carbon, it will need to react with what is the molecular weight of oxygen? It is 32 gram of oxygen to form this carbon dioxide, which will be 32:44. So this relation we know that from 12 gram of carbon, 44 gram of CO2 will be produced. So if you have got a certain X gram of carbon from CHNS, you are getting there. So how much CO2 can be produced? So such kind of things can be estimated by using the ultimate analysis results. Then moving on to the next question, this will be a numerical type question and I will give you about 5-10 minutes to go through it and share your answer. The write the answer here. So you have got a waste, solid waste, whose moisture content is 68%. Fine. And that solid waste, the initial solid waste, it is being placed inside a crucible and the initial weight of SW solid waste plus crucible, it is 50.23 grams. And the empty weight of the crucible once it has been dried, the empty weight of the dry crucible, it is this much. So you have to determine what is the dry weight of the solid waste. So this is the question. Moisture content is provided, initial weight of the solid waste along with the crucible it is provided, empty weight of the dry crucible is provided, and you have to determine what is the dry weight of the solid waste. You can have about 10 minutes for this question. Okay, I can see that one of you have answered the question. I will wait for some more time for others to attempt it. Okay, so I can see that most of you have attempted this question correctly. So I will just share with you the answer. Fine. So we know that MC is moisture content. It is equal to moisture in grams into 100 divided by total mass of waste in grams. So based on this, so the moisture amount of moisture present will be the initial weight of the solid waste, which will be 50.23 minus 30.63, and let's say the dry weight of the sample is x, fine, divided by the total weight of the sample, which is 50.23 minus 30.63, and finally this will be multiplied by 100. Now then moisture content, we know it is what, 68%. So then balancing these things, we will finally get the answer as almost most of you have correctly stated, 6.27 grams. This is the initial weight of the, so this is the initial or the dry weight of the solid waste. This is the correct answer. So now moving on to the next question. You have got four properties which are ignitionability, corrosivity, you have got reactivity and toxicity. So a waste which is exhibiting all these four characteristics: ignitionability, corrosivity, reactivity and toxicity. What kind of waste is it? Is it a C and D waste? C and D waste means construction and demolition waste. Is it a hazardous waste, an agricultural waste, or a household waste? Which kind of waste exhibits these properties? Yes, I can see most of you have attempted or chosen the correct answer. That is option 2. A hazardous waste is one which shows such characteristics. Fine. So quickly moving on to the next question. This is again a numerical type of question where the energy content of solid waste is 210 kilojoule per kg. This is the energy content. After that, you have got moisture content of the waste is 9% and ash content is 6%. So you have to determine what is the energy content of the solid waste in moisture free basis. This is one question, one part. What is the energy content of the solid waste from moisture free basis context, and then another one is from ash free basis, ash free and dry basis, both. So 210 kilojoule of energy content per kg of the solid waste, which has got 9% moisture content and ash content of 6%. So what will be the energy content be if it is, I am talking in terms of moisture free basis? One question is that, and another is what will be the energy content if it is both ash and moisture free basis? Your correct options are, I will give you them. In the meanwhile, you can attempt the question. All the values of the options will be in kilojoule per kg. So these are the options. Stands for, the first one stands for the moisture-free basis, and the second ones are for ash-free dry basis. So which is the correct answer? Anyone who has solved the question? The moisture-free basis, it is kind of more like a unitary method. 210 is the energy content for the entire wet waste. So if I reduce from that 100% of the waste, if I reduce 9% of the moisture content, I remove it, then the answer will be 210 divided by what is the remaining 91% of the dry waste. So divided by 0.91. Similarly, if both ash as well as moisture, both of them are removed, then it will be like ash plus moisture is 15%, then the remaining will be 85, so it will be 0.85. So based on that, the answer will be around 231 for this and 247 for this part. So your option 2 will be the correct option. Now, next question. Okay, so you have to determine the moisture content. You have to determine the moisture content of solid waste which has got various components. I will just write the components here. Okay, so this is the scenario. You have got the components, you have got their mass composition, moisture content of those components. So now you have to determine overall the solid waste, what is its moisture content. You can calculate at the same time. I will give you some options. So for those who have just joined or who have been joining, in this particular question, you have to determine the moisture content of the solid waste, the entire mix of it. So component wise, you have been provided their percentage mass as well as the moisture content. So you may have about 5 minutes, 5 to 7 minutes to solve this and share the answer. Okay, so I can see few answers there. 19.5, 22.75%. Anyone else? Okay. Okay. So please continue attempting the question. In the meanwhile, I will also just try to calculate and find what is the answer that I am getting. So basically, you need to find the moisture content. We know that the moisture content is mass of moisture, total mass of moisture divided by the total mass of waste.
So
So it is
22.75.
okay, 22.75. Most probably it is the correct answer. We will also just quickly calculate it. So this is all given in percentages. So assuming that this entire one is 100 kg, based on this, what is the mass of moisture? Very simple, 15 into 70. So not 70, it should be 0.7 because I'm talking in terms of percentages. Similarly, plus 45 into 0.05 plus 10 into 0.06, again plus 10 into
Hello, sir. Your mic is not on.
sorry, okay, sorry, sorry, pardon me. Okay, so 22.75 is the correct answer most probably. So still I'm just solving it again to just verify whether this it's the correct one or not. So basically moisture content, total mass of moisture divided by the total mass of waste. That is what you can understand that I am calculating. This is the mass given in percentages: 15%, 45%, 10, 10, 15, and 5. Total it is 100%. So assuming that instead of percentages, these are all 15 grams, 45 grams, and like that. And with each having this respective moisture content, I am calculating the total mass of moisture like this. 15 into 0.7% of it, that is the moisture, mass of moisture. So continuing with that, 15 into 0.6 plus 5 into 0.02. Now whole of this, it will be divided by the total mass of weight, which is 100. So those who are getting 22.75, is this the correct approach to do that? Can someone verify? So 15 into 0.7 plus 45 into 0.05. Yes, 22.75 is the correct answer. So the result for this is, it will not be in percentages the way I am calculating, it will be in fraction. So 0.2275, or this is 52.7, sorry, 22.75%. So now moving on to the next question. It will be again a numerical type of question following similar pattern, but instead of moisture content, you have to determine the density. Fine. So instead of moisture content, you have to find the density of the overall solid waste, where food waste will be 15 and its density is in kg per cubic meter. So these are the densities and these are the mass percentages. So you have to determine what is the overall density of the solid waste. In the meanwhile, I will put some options here, and all the options are in kg per meter cube. So these are the options. You can take some time to calculate it. You can share your answer on this chat box, or you can speak it up as well, unmute yourself. This can be solved in the similar way we have solved the previous question. That can be one of the ways to solve it.
Sir, 91.24 kg per meter cube.
91.24.
Yeah, sir.
Okay, fine. It is very close. Almost I can say it is correct. 91 is the correct answer. So if it is 0.24 more or less, it is fine. So anyone else getting any other answers? You can solve it similar to how we have done in the previous question. So you have to determine the density, and density means mass divided by the volume. So total mass, I am assuming that this entire column, everything is in grams. So the total mass is 100. That thing is sorted. The individual ones you need to find out. So that will be divided by the total volume. So if you have got a 15 gram of food waste, what will be the volume that it occupies? It will be 15 divided by 290. That is one component's volume. Now you have got 45 gram of paper. Its density is 85, 45 grams or kg, whatever that can be. So for example, it have got 45 kg of paper. Its density is again 85 kg per meter cube. So what will be the volume? So the volume will be 45 divided by 85. So like that we will do for all the components. Finally, for tin cans we will be doing 5 divided by 240. In this way we will have the total volume. So total mass divided by total volume, you will get value of close to 91 kg per meter cube. If you have any doubt, you can please unmute yourselves and clarify them. So moving on to the next question, this is a true and false question. So the statement is, so this is the statement. What do you think? Is it true or false? Okay, most of the answers that we are getting, it is false. Okay, let's see. So toxic listed wastes typically contain harmful chemicals, indicating that it could not threaten the human life. So of course it is false, because if it is containing harmful chemicals, then it is bound to threaten not only human life but also the environment. Also, it is a threat. Hence, special regulations are not needed to. So it is absolutely absurd sentence. So it is false. Correct answer. Then moving on to the next question. It is a multiple choice question, and your options are: which arrangement is generally used for gas collection at a landfill? Your options are: these are the four options that you have. Which of these is used for collection of gas from landfill, especially the bioreactor landfills? Okay, so Manu has chosen gas collection wells as the correct answer. Anyone else? Okay, so fine. So the correct answer is gas collection wells. I will show you one diagram. In here, you can see that these are the vertical and these are the horizontal gas collection wells. So these black dots, these are perforations. Due to the pressure difference, the methane or the landfill gas, not just methane, the entire mix of gas, it passes through these perforations because entire landfill it is covered by a geomembrane cap. So ideally the gas can't escape through these points. So when you provide these collection wells, let it be horizontal or vertical, and these are open to a lower pressure, so there is a pressure difference or pressure gradient generated. Inside pressure is more of the gas and outside is less. So naturally the landfill gas it starts going from this collection pipes to the desired points, which are called gas collection wells. So therefore these are named as. And now the other components given in the question, they were leachate wells, geomembrane and liner. As you must have already known that leachate well is a well which collects the leachate. So when we construct a landfill in a proper way, so the base of the landfill you can see that it is not horizontal, it is inclined. So it can be like this also, or the base can also be made like this. I will just draw it here. So the landfill base it can also be like this. So you can see that the pipe which is present, the cross section I will show you, and this is the leachate collection pipe. So this is the cross section. You can see that this pipe it passes through the lowest point in the landfill because whenever the leachate is formed, it will seep through the entire waste mass that is there, then slide down to this lowest point and kind of collect here. So if I put my landfill this leachate collection pipe here, it will pass through it and then move to a leachate wet well or leachate collection well, from where it is further sent for different treatment techniques to reduce its organic load and pollutant or contaminant levels. Other part was geomembrane cap. You can see that it is passing or it is applied throughout the entire outer surface of the landfill and below it as well. And then we have a geomembrane liner here also, geomembrane liner below and geomembrane cap above. The cap is used to prevent the leakage of gas, and the liner below it is to prevent the seepage of this leachate into the ground, which if occurs can be a huge risk towards the contamination of the groundwater. So moving on to the next question, which is also the final question. Which of the following is the most severe environmental effect of improperly dumped liquid? Okay, so this is a question. Which of the following is the most severe environmental effect of improperly dumped liquid hazardous waste over land? So your options are So which of these do you think is the correct answer? Okay, right away, groundwater contamination. Most of you are rooting for that, and that is absolutely the correct answer because it is liquid. If I dispose that highly hazardous material loaded liquid onto the land, it will seep through it and has huge threat to contaminate our groundwater. So option B is the correct answer. So these were the questions that we had in store for us today. I will quickly go through them again for those who have joined a bit late in today's live session. So the first question was acetic acid is formed in landfill degradation process which forms as a substrate for a particular kind of microbe. So which of these four types of microbe uses acetic acid as a substrate? This was one part of the question. Another part was which is not written here. It was what are the phases of degradation in landfill or in any other anaerobic process, like how acetic acid is formed. It is on that. So for the first part, like which kind of microbe it consumes acetic acid or uses it as its substrate, the answer is methanogenic bacteria. I will show you quickly everyone one PDF here. Okay, so it might not be visible to you. Fine, so I guess my screen is visible. So anaerobic digestion, it occurs in landfills or any other anaerobic treatment. There are the processes involved in there are first in the waste or any other feedstock, it is consisting of carbohydrates, fats, and proteins. So the degradation begins with hydrolysis. The water it starts breaking the bonds of these macromolecules to form smaller molecules, which include the carbohydrates they break down to form sugars, fats they break down to form fatty acids, proteins they break down through hydrolysis to form any amino acids. So once these are formed, after that the step which occurs is acidogenesis. In acidogenesis, you can see that volatile fatty acids are formed. Some amount of acetic acid, hydrogen, carbon dioxide can also be formed, but mostly it is VFAs. And in acidogenesis, in this step, the VFAs these are consumed as substrate for the acetogenic bacteria, which finally form acetic acid mostly, along with hydrogen and carbon dioxide, based on the kind of microbe I am having. Finally, in methanogenesis, as the name itself suggests, it is the stage where the methanogens, the kind of microbes which are active in this phase, they consume acetic acid, use it as its substrate, and produce methane and carbon dioxide. So this is the basic flow diagram for any anaerobic digestion process. This is one point that I would like to share with you, and I will just quickly see if there is anything else interesting in here. Nope, that was it. Okay, so this was the first question. Then in second question, it was asked that during the different phases of landfill stabilization, the stabilization of a waste in a landfill, at which phase is the biochemical oxygen demand highest? In here, the correct answer was the acid forming phase. And to support that, you can see this particular figure. You will see that first there is a preliminary aerobic phase where both BOD, blue colored line, and VFA, that is the volatile fatty acid concentration, both of them have started increasing and they have reached a peak in acid forming phase, after which as the methane formation starts in methane forming phase, there's a reduction in both BOD and VFAs which become more or less constant at some place in the methane forming stage. At the same time, whenever the VFA, that is volatile fatty acid concentration, is high, more acids means lower pH. That is why we see the formation of the leachate in those phases. They are often having very low pH as compared to the methane forming phases. The reason why the pH has risen more towards the methane forming phase, it can be because the methanogens, they couldn't function properly. Most of them may become inactive or die when there is an acidic or basic pH, because they are more suitable or more apt to function at around neutral pHs. So that was the reason. Now, a few other points that were discussed in here was that whenever we are talking about BOD, which is the biochemical oxygen demand, the usual standard is we measure BOD for an incubation period of 5 days and an incubation temperature of 20 degrees centigrade. So the reason was, we discussed about the reason that why we have got that 20-day incubation, so 20 degrees centigrade incubation temperature and that 5-day incubation period. So the main reason behind this was not due to any logic that, let's say, 60% of the waste is getting degraded. Practically, it is not there. The reason was that this BOT5 at 20 degrees centigrade was like formed in England, with the basic idea being the point where the BOD was being calculated, it was on the bank of River Thames. So the people there, they thought that, okay, I am dumping my waste here, and approximately they knew that within 5 days that waste which has been dumped into the river based on its flow velocity, in 5 days it would reach the ocean or sea. So the target was that before it reaches there in 5 days, the waste material should be degraded. So that was what motivated them to choose that 5-day period. And why the 20 degrees centigrade temperature? It is also based on the geographic significance. England, it is not a place where very high temperatures we see around, like these days, it has risen quite significantly. But at the time when the BOD5 at 20 degrees centigrade was formulated, at that time it was more or less around 20 degrees centigrade. So that is why this became a standard 5-day incubation period and 20 degrees centigrade incubation temperature. But again, when we come to a warmer places like India, where the temperatures are high, then we don't need to wait for 5 days and keep a temperature of 20 degrees centigrade. We often accept BOD values which are incubated for 3 days and at a temperature of 27 degrees centigrade. It is also widely accepted. So this was one example and case study. And now another point discussed was that, for example, if we go to any wastewater treatment plant or any other industry who are generating effluent and are supposed to treat it and then dispose it to some water body or land or whatever. And ideally, Indian government, they have imposed certain guidelines, certain regulations so that they first treat their water to a certain extent and then only they can dispose it. So as an environmental engineer or an audit officer, you have to go there, you have to check whether they are properly treating the wastewater or not. For to ascertain that, you need to determine its BOD. Among many parameters, let's say BOD is one of them. So you can't just wait for 5 days or 3 days to determine that value because you have got n number of sites to visit. So what can be a quicker way? It can be like you will go there, you will determine the chemical oxygen demand, and we know that for different varieties of waste, there is an established relationship between BOD and COD, which is often known as the BOD to COD ratio. For example, for easily biodegradable waste, it is often 0.67 close to. So we have those data with us. What could the BOD be? What proportion of COD? So quickly, I will calculate the COD by using potassium dichromate and H2SO4. That methodology, it is very quick, and then correlate it with BOD to determine its value. So that is how we usually do when we go for site visits. So it was about that. Then in the next question, it was also something about the hydrolysis, acidogenesis, acetogenesis. I will quickly check which question was that. Okay. Fine. So the next question was, in a landfill during waste stabilization, what is the typical composition of the gas generated at that phase? So ideally, or not ideally, like generally, it is around, we already know that in landfill there is an anaerobic condition there mostly. So in anaerobic conditions, we see methane and carbon dioxide. So with the help of a certain figure, I can show you that in this particular figure, in the methane forming phase, you can see here that methane formation is around 60%, while the CO2 is lower than that, around 40%. So that is why a typical thumb rule kind of stuff that we see in a stabilized landfill is that methane formation is 60 and carbon dioxide formation is 40%. So that was it. Then next question was about TCLP test, which is the toxicity characteristic leaching procedure. So two statements were given. Statement A, that is an assertion where it was stated that in TCLP, the size of the solid waste particles, it is reduced to less than 1. And the reason which was stated was that the finer the particles, the more is the surface area, and thus it increases in improving the reaction rate significantly. So these were your options, whether one of them is true, whether which is the reason, which is not like that. So in that respect, with that respect, you can very easily understand that in a TCLP, the first statement is correct, that initially the particle size is brought down to less than 1 centimeter. And the reason behind this is that when you reduce the particle size, the total surface area of that solid waste it increases. Resultingly, when you dissolve it, or not dissolve it, when you disperse it in a solvent system, acidic solvent system, there is much more surface area of the waste material to interact with the aqueous phase. Resultingly, more surface areas interacting or taking part in a reaction, which increases the reaction rate significantly. So that was the reason. Okay, so next question was TCLP test simulates the worst case scenario of a waste leaching ability within the MSW landfill, municipal solid waste landfill. So this was a true and false kind of question, and you can clearly understand that the answer is true because that is what basically TCLP does. Then the other question was that, for example, if you have a waste to energy kind of facility where you put in your solid waste, you burn it, combust it, and then generate the energy. So in such a facility, if you are receiving a kind of waste which is having very high moisture content, then what will happen? So among the different options, you can see here it is somewhat related to latent heat of vaporization of water. So the correct answer was that when I am receiving a waste which is dry, mostly containing paper, plastic, things like that, the calorific value is shooting up. So when you burn that waste, you get much more energy because that process, combustion process, is basically an exothermic process. Heat or energy is generated. Later on, you can use that heat to produce electricity or use it as heat itself for various other industrial activities. Now, if you are getting a waste which is having very high quantity of moisture content, then what happens when you burn it? A huge fraction or a significant fraction of the generated energy that goes out to convert that moisture liquid aqueous phase to gaseous phase to vaporize it. So that is why the latent heat of vaporization is an energy consuming step and it reduces the overall energy generation from the process. That is why the high moisture containing waste should not be treated as a feedstock for waste to energy plants. If you have any high moisture content waste, which can be your sewage sludge, which can be your food waste from hostels and restaurants, one way you can treat them is that you can anaerobically treat them if it is a solid waste. And if that waste is having a little like not as high moisture content as sewage sludge, but somewhere less, around 30%, I think, 30, but yeah, around 30%, then you can also use it for composting after segregating it at some level. So this was about the waste management stuff. Then the next question was, why do we perform ultimate analysis? And your options were, it is performed either to estimate the chemical formula of the solid waste, to quantify the amount of gases that can be generated, both the above options or none of the above. So the correct answer here was both the above options. Reason being, what is ultimate analysis? In ultimate analysis, we basically determine the carbon, hydrogen, nitrogen, sulfur, and oxygen content of a waste. Okay, so based on this, we can derive a chemical formula of the solid waste based on these 5 elements. So that is option A is true. Then option B is it can also be used to at some level quantify the gases. It cannot be an exact quantification because what happens if, for example, my waste has 100 kgs of carbon, when I burn it or combust it completely in oxygen, it is supposed to convert to CO2. So in this particular equation or this particular stoichiometry, you can see that carbon plus oxygen, it becomes carbon dioxide. And in terms of molar weight, you will see that 12 grams of carbon reacts with 32 grams of oxygen to form 44 grams of carbon dioxide. So based on it, apply unitary method. You have 100 kgs of carbon, how much CO2 will be generated? So that is ideally how we can quantify gases. But in the industrial level or at commercial level, it is not necessary that you will see complete combustion of carbon. We often hear that carbon monoxide is also generated due to incomplete combustion of carbon. So all of those uh, things keep on occurring. The entire reaction is not always perfect as we expect it to be. So that is why we can use it to kind of quantify to a certain with a certain confidence, but not exact. Then the next few questions were related to the numerical based questions, wherein we have got a solid waste whose overall moisture content is 68%. Then the initial that solid waste, it is put into a crucible, and the initial weight of that solid waste along with that crucible is 50.23 grams. Then you have been provided what is the empty weight of the dry crucible, also 30.63 gram. And finally you were asked to determine the dry weight of the solid waste. So it was very simple. You can see that we know that someone is trying to join the meeting. Okay. So you can see that the moisture content, the formula, we all know it is the mass of moisture divided by the total mass of waste. Very simple. So what will be the mass of moisture be? So we have got the initial wet waste plus crucible is 50.23 minus subtract the dry weight of the crucible, you will get the initial weight of the wet waste, that is 50.23 minus 30.63. This 30.63 is the mass of the crucible. So when you subtract it, you are left with the initial weight of the solid waste. Let's say X is the final weight or dry weight of the solid waste, dry weight. So when you subtract the dry weight from the initial weight of the solid waste, you are getting moisture content of the mass of moisture. So in numerator you have got the mass of moisture, in denominator you have got the total mass of waste. Multiply it 100 and put it into the equation, you will get the value of X as 6.27 grams. So that was a very simple question that we solved today, followed by another question wherein you were told that a waste is there which exhibits these four qualities. First is ignitionability, corrosivity, reactivity, and toxicity. Ignitionability, we all know it means it quickly catches fire. Corrosivity means it can corrode various surfaces. Reactivity means it can react quickly with its surroundings and may transform into something else. Toxicity, we all know it can be toxic to both humans and animals as well. So if a waste is showing all these four characteristics, which kind of waste it can be? So the correct answer was hazardous waste. Then again, the next question that we solved, it was a numerical based one, where you were told the energy content of the solid waste, which was 210 kilojoule per kg. So that solid waste, it also contained a moisture content of 9%, ash content of 6%. Based on this data, you were asked to determine the energy content of the solid waste on a moisture free basis. So it is very much ascertained that if I am removing the moisture from the solid waste, just in that waste to energy question that we attempted a few slides ago, the overall energy will increase, because overall the total energy content of 210 kilojoule per kg, it is for a waste which also has a moisture in it. So if you remove the moisture and then burn the waste, of course you will going to get much higher energy, because the latent heat of vaporization of water, that is not being consumed. So that is why 9% moisture content is there. How much is remaining the solid waste? That is 91%. Divided with it, 231 kilojoule per kg is the correct answer. Similarly, if you want to determine it for ash free and dry bases both, then you have to subtract from 100% both the amount of moisture and the amount of ash. In the similar way, you can get that as well. Why ash free is again giving you higher energy value? Because similar to ultimate analysis, which we went through a few slides before, in proximate analysis of a waste, what we do is that we try to draw a composition of that waste with respect to the amount of fixed carbon it has, the volatile matter it has, the moisture content it has, and the ash it has. So what are these stuff? Fixed carbon, I will talk about later. First, the easy part, moisture content. We know moisture content what it is. It is the amount of moisture that is present there, water. Now, what is volatile matter? As the name itself suggests, volatile matters are materials, the compounds in that waste which are much volatile in nature. That is, they tend to easily transform to the gaseous phase. Those are the volatile matter. And then what is the fixed carbon? Fixed carbon, you can kind of understand that once the volatile matter is gone, the amount of carbon among the total carbon can be fixed carbon plus volatile matter. So once the volatile matter is gone, you are left with the fixed carbon, which is not going to just volatilize. Then another part is ash. Now, ash, we all know, we burn something out completely. What is left behind is ash. When I am completely burning a solid waste, I'm completely burning all the carbon present in there. So every ounce of carbon, it will go away, and the material that will be left behind, it will be ash, which can comprise of silica, it can comprise of sulfur, it can comprise of your alkali and alkaline earth metals. Those oxides, they are often found in ash. So these are the basic components. And when you calculate like among these moisture content, fixed carbon, volatile matter, and ash, which are the components which actually provide me with the energy that I can use later on at some for some application. So that will be primarily it will be fixed carbon, followed by volatile matter content also aids in uh, improving the fuel value of a solid waste or any other material, but there should be a balance between them. So one thing is very sure, if I want to improve the energy value of a solid waste or any other solid product, I need to reduce both its moisture as well as its ash content, because that ash, it doesn't take part in combustion and it doesn't give us any energy. So when I try to calculate the energy content based on an ash free as well as dry basis, with that aspect I am getting the highest energy content of the solid waste. So this was it. Followed by the next question was related to the moisture content of a solid waste. In there, we were presented with a table wherein different components are present in a solid waste: food waste, paper, cardboard, plastics, garden trimmings, and tin cans. We were provided the mass percentages of all these components along with their respective moisture content. And you were asked to determine, like, overall, what is the moisture content of the waste, entire mix of it. So it is also very simple. When I am asked to determine the moisture content, what I have to do is that I have to divide the total mass of moisture present in a waste divided by the total amount of waste multiplied by 100. So for example, these are all in percentages. Let's assume that these are in kgs or grams. So 15 gram of food waste is there, out of which 70% is moisture content. So how much is moisture? It is 15 into 0.7. So like that, I will add all these up. In here you can see. So finally, I will get the total moisture divided by the total mass, which was 100, and then I can get the moisture content. Finally, the next question was related to the density of the solid waste. Here also similarly, the mass percentages remained the same, but instead of moisture, we played with the density of each component of this solid waste. So what is density? We know it is mass divided by volume. Total mass, if I assume each thing as in terms of kg, total mass is 100 kg, and now I have to divide it with total volume. So in order to calculate total volume, I will sum up the individual volume of each component of the waste. So if I have got 15 kgs of waste with a density of 290 kg per meter, so what volume will the food waste occupy? It will be 15 kg divided by the density. So that will be the volume occupied by the food waste. Similarly, I will sum up the volumes occupied by every component and divide it, and and use that value to divide 100. That is the total mass of solid waste, and simply we will get the density. These are all very simple basic level questions. Then finally, we had the next question wherein it was very simple statement. It was given that a toxic listed waste typically contains harmful chemicals, indicating that it could not threaten the human health and environment. So it was a true and false one, and anyone can clearly say that it is absolutely false. So it was that. Then finally we had the question wherein it was asked that for collecting the gas generated in landfills, what do we use? In here you had got several options starting from gas collection wells to leachate wells, geomembrane and liners, wherein the correct answer was vertical and horizontal gas collection wells. they are being used to collect the gas generated in a landfill. So this is one diagram where you can see that these are the vertical and these are the kind of horizontal gas collection wells. The landfill gas that is generated inside the landfill, it is kind of in pressure, and since these gases, they are kind of open to a low pressure points, so due to the pressure gradient, it moves from inside the landfill, passes through this wells and goes out from where it is collected. Now geomembrane is used as a cap over the landfill to prevent the entry of water and air or leakage of the same. Then I have got geomembrane liner, whose job is to prevent the leaching of the or leaking of the leachate into the soil and finally reaching the groundwater. It has to prevent it. And then I have got the leachate collection well, whose name itself suggests that in the landfill you can see that there is an inclined slope. The leachate that is seeping through here and collected, reaching the bottom, it will move through this gradient and get collected at a lower point. So these were the roles of different components of the landfill. Finally, after that, we had this question wherein it was asked which of the following is the most severe environmental effect of improperly dumping a liquid hazardous waste over land. And in here, the correct answer was the highest risk was posed to groundwater contamination because that liquid, along with its various dissolved contaminants and pollutants, it can seep through the soil, and if it reaches the groundwater level, that can be a very, very threatening situation. So these were the couple of questions, about 15 questions that we discussed today. If you have any doubt on it, any points that you would like to share, or add something to these questions, please feel free to unmute yourselves and share that with everyone here. And otherwise, we will be meeting next Tuesday, same time from 7 to 9 for the week 3 live sessions. Anyone wants to add anything, you are always welcome to share your points, your opinion. If not, I would like to just highlight, like, uh, this is not, it is not mandatory to stay in the meeting throughout the time. If there is nothing that you would like to share something with us or you have read, you can leave at your own convenience. Thank you, Manu, for being here in this live session. Hoping forward to see you in the next session as well. Okay, so thank you everyone for joining. Thank you everyone for joining this session. Thanks a lot. Looking forward to see you all in the week 3 live session. Thank you.